Welcome to The Explainer. Today, we're diving into a technology that's about to totally change how we see our own planet. And I mean totally. This stuff is moving out of the lab and, yeah, directly into orbit. So let's just start with a huge question, one that really gets to the heart of why this matters to every single one of us. What if we could actually see the invisible signals our planet gives off before a disaster even strikes? All right, here's the game plan for today. We're going to look at why our current tech is hitting a wall, then dive into the incredible new quantum toolkit. After that, we'll check out who's leading the global race, see how countries are teaming up, and finally, wrap it all up with what this means for you and me. Okay, let's dive right in. To really get where we're going, we've got to start with the problem we're trying to solve in the first place. For decades, we've had these amazing tools, satellites, radar, you name it, predicting our weather and modeling the climate. And they've been great. But here's the thing. To tackle the challenges we face today, like crazy extreme weather or rising sea levels, we need a whole new level of accuracy. Our current tech, as good as it is just, well, it's hitting a wall, a fundamental limit in precision. And this is where things get really interesting, because we're not just talking about a small upgrade here. This is a fundamental shift. We're not just making our old tools a little bit better. Nope. Quantum sensing is a whole new way of doing things. It's this massive leap that lets us measure the world with a resolution we've never even dreamed of, all by using the weird, amazing properties of atoms themselves. So, okay, if our old sensors are maxed out, what's the answer? Well, it's time to meet the new toolkit. First up, we have something called cold atom interferometers. Now stay with me here. At the quantum level, atoms can act like waves. And these devices, they basically create these delicate patterns from those atom waves. The amazing part is these patterns are so sensitive, they shift with the tiniest change in gravity. You can think of them like scales, but so precise they can literally weigh the pull of gravity itself. This tells us what's happening deep underground, completely out of sight. And just think about how powerful that is. With this, we can track water reserves deep underground to manage our drinking water. We can measure exactly how fast the polar ice is melting. We can even see where floodwater has soaked into the ground after a disaster. It's incredible. Okay, next up in our toolkit, optical clocks. And this is where things get, well, kind of mind-bending. This is straight out of Einstein 101. His theory of relativity tells us that time literally runs at different speeds depending on how strong gravity is. And these clocks, they are so unbelievably accurate, they can actually detect that tiny difference. So what does that mean? It means they can measure a change in your height down to a single centimeter just by measuring how the flow of time has changed. Yeah, really. And believe me, this isn't just a cool science trick. That kind of insane precision is absolutely vital for monitoring sea level rise. It gives us a much clearer picture of the risks that millions of people living in coastal communities are facing right now. And the last tool in the box is quantum LiDAR. The easiest way to think about it is like a supercharged version of the LiDAR we already use, but by using the quantum properties of single photons. We're talking individual particles of light here. These sensors can scan the atmosphere and sniff out specific gases with a sensitivity that was just impossible before. And the uses for this, oh, they're huge. We're talking about spotting methane leaks, a really potent greenhouse gas, all the way from space. In fact, a UK company called QLM is already doing this with energy companies. Plus, it helps us fine-tune the wind data that makes our daily weather forecasts more accurate. So, yeah, big deal. All right, so now that we've seen the tech, let's zoom out to the global stage. Because this incredible technology is kicking off a whole new kind of race, a geopolitical race for innovation. This chart gives us a really great snapshot of who's doing what around the world. So you can see Europe, we're talking France, Germany, the UK, they're moving fast on the business side, with companies like Exail and QLM already selling products. The US, on the other hand, is playing to its strengths, using its deep research base at NASA and NIST to build this super powerful foundation. And then you've got Japan, just totally leading the pack on those ultra-precise optical clocks we talked about. So you can really see the different strategies here, right? Europe is all about getting products to market early to grab that leadership spot. The US is playing more of a long game, building this huge research pipeline that could pay off big time down the road. And Japan is just dominating a critical niche.
It's fascinating. It's not just one single race. It's like several different races all happening at the same time.
But this isn't just a story about competition. It's also about some really critical international teamwork. Because the truth is, no single country can do this by themselves. And this teamwork is happening right now all over the world, mainly because these missions are just so complex and so expensive. You've got the US and Germany working together up on the International Space Station, testing this tech in orbit. The entire EU is pooling its resources for a mission to launch the very first quantum accelerometer into space. You even see it in security packs like AUKUS, which includes quantum sensing that has obvious climate uses. And then you have countries like Canada and the UK teaming up specifically to get these inventions out of the lab and into the real world. These partnerships are absolutely crucial. They split the huge costs and speed up the science, which means we all get to benefit from these tools much, much sooner. Okay, so let's bring this all back down to Earth. What does all this actually mean for our future, for our day-to-day lives? I think this quote says it all, really. This is the key takeaway. This isn't some science fiction idea that's decades away. The future is literally arriving as we speak. We have prototypes that are already working. We have missions being prepped for orbit. And we have commercial products already out there in the world doing their thing. And what's the bottom line here? Well, all this progress translates into real, tangible benefits for every single one of us. We're talking more accurate weather forecasts, a real, honest-to-goodness way to track greenhouse gases and see if we're hitting our climate goals, and way better tools to help us prepare for floods and droughts. This technology gives us the information we need to get ahead of problems, to be proactive instead of just reactive. So this leaves us with one last kind of big thought. What we're really doing here is building a new sensory system for our planet. Think about it, a network of quantum sensors in space and on the ground that can feel Earth's pulse in real time, almost like a planetary nervous system, one that could help us understand, predict, and ultimately protect our world in ways we've never been able to before.